Hey guys, and welcome back to another video on the channel. In today's video we're going to be doing part 2 to the 2021 Math Methods paper 1 tech free for the QCAA syllabus. So we've already done part 1 which covered over these questions, so from question 11 pretty much down to, where was it, this one here. This one's all pretty much clean, I've rubbed it all off. So we've gone up to that question and we're just going to be continuing the questions in this test. If you have any questions at all in this video with any of the questions, leave a timestamp and ask your question. I'll try my best to answer it, okay? But let's just get straight into the information, okay? So question 16 worth 4 marks. Now you are able to use the methods formula sheet as well. That will be given to you in the test, but this one is strictly calculator free, okay? A tangent is drawn at the point 1e on the graph of the function y equals e to the power of 2 minus x, as shown, okay? So here we can see there's the tangent, that straight line, and we can see our exponential, okay? Determine the area of the shaded triangle. Well, first of all, with this question here, we need to work out what the side lengths of this triangle is, okay? Now, obviously we know it's right angle, and then you could use area as a half base times height. However, we need to work out pretty much what those side lengths are, okay? Now, you can do it that way, or you can integrate the tangent line. But we've got to figure out what that is, regardless of which way you're going to do it, okay? So first of all, to find the tangent line, you need to find the gradient at this particular point here, okay? So here, this is at 1e. So here, that's e, and that is 1, okay? So here, we've got to differentiate this function. So here, your m of your straight line here will be dy dx at x is equal to 1 here, okay? So here we're just going to differentiate this guy. So y equals e to x minus x. Differentiating this is going to be a chain rule. So differentiating the inside function. So the derivative of this would be -1. So it's going to be -1 times by, and then the derivative of e is just going to be e. So it's just the original function there, okay? So the only thing that changes is it just becomes negative at the front, okay? So your derivative is negative e2 minus x. So we want the gradient there. We just chuck in x equals 1 now. So dy dx at x equals 1. So that will be negative e2 minus 1. And pretty much that's going to be e. So it'll just be negative e. So the gradient there is negative e. So this is what we know. Okay, it's a straight line. Y equals mx plus c is the general equation of a straight line. Okay, we know the gradient is negative e. And we know the point is 1e. We have everything we need to work out this information because we can just substitute that into there. You can then substitute the x value into there, and you can also substitute the corresponding y value at that point there as well. So you can find your c. So if we do that straight away, we'll have y, we can replace with e, equals negative e times by 1 plus c. So here we have e equals negative e plus c. Move the e across by adding it to both sides, so you're going to have 2e equals c. Therefore, my line will be y equals negative e x plus 2e. Now that is an annoying and weird equation. However, e is just a number. E is about 2.71, okay? You've got to be comfortable with that, okay? So this is just our line. So we can find the side lengths here if we wanted to. Now, that's going to be more additional work than actually just integrating, okay? We can just find the area under this curve here by integrating from x equals 0 to whatever the x-intercept is, okay? So rather than find the y-intercept as well, even though it's already given there. So I'll show you actually both ways how to find it. So we'll do this one first. So the x-intercept on your tangent line is when y is equal to 0. So you have 0 equals negative ex plus 2e. Move the 2e to the other side, so it's negative 2e equal negative ex. Divide by e, or actually negative e on both sides. So that e will cancel out, and the negative will turn positive, so it'll be positive 2 equals x. So that point there is 2, 0, okay? So the area under this curve will be the integral from 0 to 2 of negative ex plus 2e dx, okay? Now when integrating this guy, it's actually fairly easy. We just add 1 to the power and divide by the new power. So the first one here will be negative ex squared divided by 2. Then we're going to have just plus 2e and attach an x to it because that has no x's involved, okay? So you're just adding an x because you're integrating. Then you have the bounds 0 and 2. And then you just substitute them in. Now if I substitute in the 2, it will give you a number. But if I substitute the 0 into either of these terms, it's just going to disappear. So I'm just going to substitute the 2 in just to save working. But this is what would actually happen still. So negative e, 2 squared over 2 plus 2e times by 2. Then you would have a minus 0 when you substitute that bound in, okay? Now we can simplify this. 2 squared divided by 2 is just going to be 2, so we have a negative 2e there. Then we're going to have a positive 4e. So adding those two together, we get positive 2e. So the area under this curve, so the area is 2e, and I'll just say units squared, okay? Now, the other way to find it, okay, you can use it doing the triangle. So you don't have to do that integral, but you will still need your tangent line, okay? So that is your y-intercept, okay? So that means this coordinate up here is 0, 2e, okay? So that means that height there is 2e, and that length there is 2. Now, area of a triangle is a half base times height, okay? So area is a half times by the base, which is 2. That will cancel out immediately, times by the height, which is 2e. So here that cancels out, and you get the exact same answer as if you were to do the integral. Does that make sense? I don't know why I'm saying that, because this is a recording, but sorry, I just used to tutoring, but yeah, hopefully that makes sense. If it doesn't, leave something in the comments, and let's just move on, okay? So next question. So question 17. In any 5-day working week, Leonardo either catches a bus to work or uses any other form of transportation. On average, he catches the bus to work 3 of the 5 days, okay? His decision on any given day is independent of his decision on any other day, okay? So from that wording straight away, I know it's going to be binomial probability, okay? Because his decision is independent of the previous one. So that means the probability that he chooses to go to work, the probability he chooses to catch the bus to work or use another form of transportation is going to be a constant probability, okay? Determine the probability that Leonardo catches a bus to work exactly 1 in a given 5-day working week, okay? So here, the probability that he catches the bus to work is 3 out of the 5 days. So it's 3 divided by 5, okay? Now, what we're after is the probability when x is equal to 1, because we want to know exactly when it's 1 day of the week, okay? Your n is pretty much 5, so n is 5, okay? Now your r is 1, just in your normal probability. So if you want the probability that x is equal to r in a binomial, that formula would be n choose r times by the probability to the power of r times by the complement probability n minus r. So in this case here, we know what n is, we know what r is, we know what the probability is. The complementary probability would just be 2 on 5, okay? So literally that plus that has to give you 1, okay? So here, now remember, this is calculated free. You've got to work this out by hand. So the probability that x is equal to 1, so he catches the bus once, exactly once in a 5-day week, will be 5, choose 1, times by 3 on 5 to the power of 1, times by 2 on 5, 5 minus 1, okay? Now, 5 choose 1 is just 5, okay? So we have 5, that's just going to stay the same because the power of 1 means really nothing. Here, that's going to be a power of 4, so 2, 5 to the 4. We can distribute that 4 now, okay? Now, we got to work this out by hand, okay? So, put that 4 to both of those powers using index law. 2 to the power of 4 is going to be 16, okay? 5 to the power of 4, that's a bit tricky to work out, but let's see what we know, okay? We know 5 squared is 25, okay? And we know 5 to the 4 is 5 squared times by 5 squared. So 25 times 25, okay? Now that's still a bit tricky to work out, but we also know this. So 5 squared is 25. 5 cubed is 125, okay? So you can just times that one by 5 as well if you want to. So you can go 100 times by 5. Then you can go plus 5 times 25. So that would give you 625. So either way, using one of those problem techniques, you'll work out 5 to the power of 4 is 625, okay? So our fraction here is 625 on the denominator. So now let's get rid of this. So a lot of the grunt work will come with just these little tricks with arithmetic as well. Okay. So here, this here, that cancels out quite nicely. So we have 3 times by 16 over 625. And then 3 times 16 is just 48. Now you have to leave it like this, okay? Because that can't be simplified by hand, okay? Well, it probably could, but not at this level, okay? And this is only year 12 level, okay? That's not divisible by that because that is an odd number, that's an even number, and neither of them share any common factors, okay? So you'd probably just leave it like that. And that's about it with question 17, okay? If you have any questions about question 17, leave something in the comments and I'll try my best to answer it. Let's move on to question 18. Alright, so question 18. The graph y equals f of x, where f of x is a quadratic function of ax squared plus bx plus 4 is shown. Two regions of the area between the graph of y equals f of x and the x-axis are shaded. So we have region P and Q, okay? Now region P has an area of 3 on 6 units squared. So that means that whole area is 13 divided by 6. And region Q is 43 divided by 6, okay? Determine the values of A and B. Well, let's work out how you actually get these areas, okay? So, this area here, so region P. So P would be the integral from -1 to 0, okay? -1 to 0 of our function here, okay? So of f of x. Region Q would be the integral from 0 to 1 of f of x. So 0 to 1 of f of x. That straight away gives me two equations for two unknowns, except we have to integrate both of them, okay? So here, this first one can be rewritten like so. Region P, that's 13 on 6, and then we just have the integral -1 to 0, and we have, what do we have? Ax squared plus bx. I'm writing my b's as capitals because otherwise they look like 6's. I don't care. I control the video. Anyway, so that's that first bit there. Hopefully you can see where I've slotted those guys in. And then for this one here, Q, let's just highlight that in yellow. We'll have 43 on 6 equal the integral from 0 to 1, and that exact same function. So really you only have to integrate it once, but you've got to put in the bounds individually for each of them, okay? So that goes there. Boom. Alright, so now let's just integrate this while we're at it. So integral of ax squared plus bx plus 4. You're just going to add 1 to the power divided by the new power because they're all power rules. There's no sign or cause or anything like that. So this first one will be ax cubed on 3 plus bx squared on 2. And this one will be plus a 4x. Now because we have bounds, now if this didn't have bounds like this one here, you would add a plus c, but because they have bounds, you don't include the plus c. So here, the green equation will turn to this. 13 on 6 is have the bounds, so ax cubed on 3 plus bx squared on 2 plus 4x, and the bounds -1 and 0. Then you'll also have 43 on 6 equals, and then you've got the exact same thing here. Let's see if we can fit it in. I hope there's additional paper. I write very large. That's okay. I'll just have to rub things out. And there's a 3 and there's a 2. There we go. So now we just chuck in the bounds. Now we've got to be smart about this. If I chuck in 0 into each of these terms, that's all going to disappear. So we're going to have a 0, then we're going to have a minus, and then we're going to have this bound here. So we would have a -1 cubed on 3 plus b -1 squared on 2 plus 4 -1 bracket bracket, okay? That's a whole thing there. So that's 13 on 6, okay? Please tell me there's more room. Oh, thank goodness. All right. Same thing here. Now, oh, actually, I made a mistake here. So hopefully you could see my little mistake. I just wrote the same bounds here. That's not that. That is 0 and 1. So we will plug in the first bound for the yellow bit. So this guy here is the yellow. If you can't remember there, it's just that one there. And this one was the green. And that's the green. I won't highlight it from now on now. So here, just chuck in the 1. So we have 4, 3, 6 equals. So you have a1 cubed on 3 plus b1 squared on 2 plus 4 times by 1. Then you'll have a minus 0 here because you've got that other bound, okay? But in the end, that's not really going to matter. Now we just want to simplify this as much as possible. So you go 43 on 6 equals a on 3 plus b on 2 plus 4. So that's equation, let's call that equation 1. This one up here, we have 13 on 6 equals, this here will be negative because negative 1 cubed is negative 1, but you've also got that negative 1 at the front. So I'm just going to simplify this first and then distribute the negative 1. So negative, and that'll be negative a on 3. That will become positive, so positive b on 2 minus 4. Okay. So here I want to see if anything cancels out quite nicely, and hopefully you can see some things will. So distribute that negative now, so change that to a plus, and change the rest to minuses, okay? So that turns into a minus, and then that one turns into a plus, okay? Get rid of the brackets, and we can probably move this a bit closer, so 13 on 6. Right, and let's call that equation 2. Now, if I add equations 1 and 2, look what we have here. We have those two adding together, but more importantly, we have that cancelling out with that. We have a variable cancelling out. So if we have 1 plus 2, if we add the two equations together, so the left-hand side and the right-hand side to get added together, we're going to have something really nice here, okay? So here, all we're going to have is, now they have common denominator, so you have 43 on 6 plus 13 on 6. Now, this isn't the only way to do it. You can minus them and it'll cancel out the a. This is just one way of doing it, okay? So here that would give you 2 on 3. That would cancel out, and that would give you plus 8. Now, remember, this is all non-calc. So, 43 plus 13. Oh, I don't know. I'm just going to use my calculator. 56. There we go. 56 on 6. 2a on 3 plus 8. Now, 56 is divisible by 6, I think. Or actually, no, it's not. I probably could get simplified, but we want to try and get a by itself now. So, we want to move the 8 across. So, 56 on 6 minus 8 equals 2a on 3. I'm going to simplify this side before I change anything here. So here 8 can become 6 on, oh wait, not 6 on 6. What's 8 times 6? 48, yeah. So 56 on 6, so 8 is the same as, so negative 8 is the same as negative 48 on 6. Now the reason I did that is so they have common denominators, okay? Now, 56 minus 48, that's going to give us 8. So we have 8, it's going to be positive on 6 equals 2 on a, okay? Times both sides by 3 and times that side by 6. So if I times that side by 3, that's going to give you, what, 24? And if I times that by 6, that's going to give you 12. Then divide by 12, a equals 2. Alright, let's see if that was correct. Yeah, it is. Alright, cool. Now once you got a equals 2, you can chuck it into equation 1 or equation 2. So what one did I do? Oh, it doesn't really matter, I suppose. I'll just choose this one up here. So we'll go 13 on 6 equals 2 on 3 minus b on 2 plus 4. So I just plugged in a equals 2 just in there. Hopefully you can see where I slotted that, okay? If you have any questions about this working, remember leave a timestamp. I'm just going to keep going it. Alright, so move that guy across. So we have 13 on 6 minus 2 on 3 minus 4 equals negative b on 2. So let's try and simplify that. So 6 and 3 are pretty close, but you just got to times the top and bottom here by 2. That way they can have a common denominator of 6. So 13 on 6 minus 4 on 6. Now while we're at it, we might as well do the same here. So 4 times by 6, what's that? 24. So you have negative 24 on 6, and just add this all together to see how this goes. So leave the denominator as 6. Oh, what is that? Oh man, I'm getting real lazy today. Alright, negative 28 plus 13. Negative 28 plus 13. Negative 15. Oh, of course it is. Alright. Now, you can see we have a negative on both sides. Times that side by 2. So you have negative 30. Times that side by 6. So you have negative 6b. Okay? Of course, you would have cancelled that as well. Now, 30 divided by 6 is 5. I'm pretty sure. Yeah, it is. I'm just joking with you. I knew the answer. Alright, there we go. But yeah, that's how you do that question there. Okay, so it can be done without a calculator. I just got a bit lazy with my arithmetic towards the end. Totally knew 30 divided by 6 was 5. Okay. It is doable. Now, this isn't the only way to do it. Especially here, you don't have to go 1 plus 2. You can go 1 minus 2. It's up to you. This one just works for me and makes more sense, okay? Right, let's go on to the next question, okay? So, question 19. A firm aims to have a 95% confidence interval in estimating the proportion of office workers who respond to an email in less than an hour within plus or minus 0.05. So, a survey has never been taken before, so no past data is available. The firm believes the proportion is 0.5. Then this will result in the largest what is that word? It's not I don't even know how to say that word. In the sample proportion. Based on this, determine the sample size of the approximate value of z equals 2 for the 95% confidence interval. Justify the choice of 0.5 for the population. So, here, we've got to pretty much argue our way through it. Now, usually you would have to remember z is 1.95 for 95% confidence interval. However, in this one here, we have to use the 2, okay? Because we want our answer to match with theirs, okay? Now, formula for confidence intervals. A confidence interval is a bar, okay? You have the center, which is your mean, and you have a max and a min, okay? It's centered around it, okay? So the confidence interval is set up like this. Your proportion plus or minus your z-score times by pretty much your, your standard deviation. So your proportion, then 1 minus your proportion over your sample size, okay? So here, this would be your proportion plus z and then all that stuff there. This would be your proportion minus z and all that stuff here, and that's your proportion in the middle. We need to work out the sample size because we've already been given the proportion in this example here. The proportion is 0.5, so we know what that is, okay? We also know what the z value is, okay? It's that one there, okay? We need to work at the sample size. Now, we've got to think about this as well, because this is, so a firm aims to have a 95% confidence interval of office workers who respond to an email less than an hour within plus or minus this. So, this is basically saying this is what we're hoping for, okay? Now, given the proportion is this, let's see if that's actually accurate and if it's a 95%, okay? So all we're going to do is just work out pretty much your sample size. So you can just choose one. So we'll go plus, so plus 0.05, we're hoping is equal to your proportion, which is 0.5, plus your z value, so that's going to be, that is your actual value there. So the plus or minus is actually just representing, oh, that's the wrong color, I wanted to use pink, just draw on that again. This here is representing this bar here, okay? They're hoping the proportion is that though, okay? So we want to see if this pink matches up with that pink. So we have to go 0.05 is equal to the z-score, which we're saying is 2 in this case here. Square root proportion is 0.5 times by 1 minus 0.5 over n. And pretty much we're just going to solve for n. And we're just going to see if that's actually realistic, okay? So here you have to times it by 2. So here we can recognize 0.05 is 1 over 20, and we also have 2 here. Now you can also look up here, 0.5, 1 minus 0.5 is 0.5. So you have 0.5 times 0.5, so that's going to be 0.25 in there, okay? Which will be a quarter, okay? So if I move the 2 across, I need to divide by 2. So here that's going to be 1 over 40 now, okay? And then we still have that square root. However, we can represent 0.25 as 1 on 4, okay? Just to make it a bit easier on ourselves. Now to move the square root across, we need to pretty much just square both sides. So it's just going to be 1 over 40 squared equals 1 on 4 on n, okay? Now here, if I times both sides by 4, that's going to get rid of the quarter, but it's still going to be 1 over n. So we're going to have times by 4, and we'll just see how we go, okay? Now 40 times 40 is 1600, so we have 1 over 1600 times by 4, okay, is equal to 1 over n. Now 4 over 1600 is the same as just 1 over 400. So here this can just get replaced with 1 over 400. Now because they're both ones, and if we had it like this, we can just flip both sides of the equation upside down. So we get 400 is equal to n. So pretty much, in order to have this confidence, well, in order to have this proportion, so 50% to be within this interval, you would need a sample size of 400, okay? Now, I don't know about you, but a firm doesn't really, well, if it's an office, you can't really have 400 people in office. Well, actually, you probably can if it's a really big corporate company, but generally, that is a ridiculous amount of people, okay? So, I would say probably the proportion is not realistic, and you have to justify the response. So here, that number is way too big, but yeah, you just pretty much have to try and justify it in like I wouldn't say your own words, you have to use bits of the data. I would say a more accurate one would be like, okay, you could decrease the confidence interval. Instead of 95%, you could say it's 90% or even 80%. Or you can pretty much just say, all right, what if we just change the proportion so we decrease that value? So if we decrease the proportion, that will change a lot. It will decrease the sample size overall. Because if this number here got smaller, then that number's got to get smaller as well. So that will decrease that sample size, okay? But yeah, so just have a justified response. Obviously have all this working in here, but you also have to have that written response as well talking about that, okay? Alright, if you have any questions about this one here, leave something in the comments and I'll try my best to answer it. Alright, so let's go into this one here. Alright, so question 20. Now, what do I do for question 20 here? Ah, yes. Okay. So question 20, I did this test beforehand. That way I'm not going in fully blind. The population of rabbits P on an island in hundreds is given by this equation, where T is the time in years. Determine the intervals of time when the population is increasing and the intervals when it's decreasing. Okay? Well, this one here, this is all to do with differentiation, okay? They want to know the time, so two values, when the population is increasing. Now, when the population is increasing, okay? Population's increasing, intervals when it's decreasing. Actually, how long is the video? I actually might make a separate part just for this last bit. Just because this video is actually going to be really long to upload onto YouTube. So, I'll leave this last question for the next video. It will only be just this question here, but it is going to be a very long question. So, I'll see you guys in the next part. If you have any questions about this part here, leave something in the comments. Overall, if you enjoyed, leave a like and subscribe, and I'll see you in the next one.